Hello everybody, I am going to make a video for today's lesson because I cannot be on class because I am going to attend a seminar somewhere in Sibunga. So for today's SLHD, it is now our, It's our fourth SLHD. This is the fourth lesson so far for the third quarter, and I think this will just be easy for you. By the way, it's 11 p.m. during this recording because I really can't be there at the time. Okay, our topic for this session is measures of describing data. We're done with describing we have the overview of how to describe data through graphical presentation, and there are also other ways to describe data. Analysis starts at this presenting of data and furthermore on looking at the meaning behind these organized values or these numbers. So for today's session, we're going to have to review a few things, and then just the overview of graphical presentations of qualitative data and quantitative data. And then the main topics are the measures of central tendency and the measures of variation. And after this, you're going to answer the exercises that are given at your SLHD. So when you're looking at your SLHD, we have there, you read through, and then at some point you will read answer this exercise number. It is better to answer that exercise right away because the topics are related. Okay, so you go through that sequence in the SLHD. Okay, let's go. So first, there are two main things that we're going to discuss. The first one are the graphical summaries of data, and second, the numerical summaries of data. Let's start first with the graphical summaries. So all of those things that we discussed, the presentation of data, they are also summaries of data. So we're just going to run through again all of these different ways of presenting data. So what are the different ways used to present data? So if you can do so, you may pause this video and comment down at the comment section on what are those. Okay, so the different types of presenting data are, we have those bar charts, pie charts, and so on. So once we have collected the data from our surveys or from our experiments, from the data gathering period, we then need to summarize and present the data in a way that it will be meaningful to the reader, to make that data a meaningful information to the audience. And that begins with the graphical presentations of data, and then exploring from then on the numerical summaries. Okay, so first we have the qualitative, presenting qualitative or categorical data graphically. So we have categorical data or nominal or ordinal data or the qualitative data. They are pieces of information that allow us to classify objects into various categories. We usually begin with the categorical data by summarizing data into a frequency table. So simple as a frequency table, just like this. So a frequency table is a table with two columns here. One column lists the categories and another, this column, for the frequencies with which the items in the categories occur, how frequent they occur, or how many items would fit into each category. So for this frequency table, the context is that an insurance company determines vehicle insurance premium based on known risk of factors. So for example, there's this insurance company that gives premiums for its customers. If a person is considered at a higher risk, the premiums will be higher at the insurance. And one of those factors that they would consider is the color of your car. So according to them, the insurance company believes that people with some color cars are more likely to get in accidents. So to research this, they examine police reports for recent total loss collisions, and this data is summarized here at the right. So they say if it's blue, 25 times are recorded on the collisions and so on. So blue 25, green 52, red 41, white 36, black 39 times, gray 23, and so on. So this simple table just tells you the frequency occurrence. Next, another way to present your data is the bar graph. So sometimes we need a level up, more intuitive way to present your data. So this is where your charts and pie graphs and other forms come in. So let's now go with the bar chart. It displays a bar for each category with the length of each bar indicating the frequency of that category. So you can do that just like this. So the frequency that we got from the previous problem looks like this. So at the vertical axis, we have the frequency here, and we have the guidelines also, so that it would be easy to see. And then here. So we have discussed in the previous meeting, for those who joined the online class, and for those who joined the, what was that? Those who viewed the PowerPoint that I sent in the group chat. So there are guidelines on how to make a bar graph. These kinds of labels here should be added. Okay. And then notice that at every point they're using a 5-mark interval for every 5 units. Okay. Next, a Pareto chart. We haven't had a Pareto chart before. So the difference is that a Pareto chart is a bar graph, but ordered from highest to lowest frequency. So just this. Okay, and there's an order. This would be easier to compare as well for the audience's view because they are ordered. Next, to show relative sizes, it is common to use a pie chart. When the numbers are having a relationship among themselves or they're related to one another, you can make a pie chart. This is a circle with wedges cut of varying sizes marked out like slices of pie or pizza. The relative sizes of these wedges here, these sections, correspond to the relative frequencies of the categories. For example, the cars in the example, car colors, just like this. So making the pie chart, it would look like this. In other softwares, we can also have this kind of arrangement. There is a label here besides. So in presenting a pie chart, just make sure that labels do not overlap from one another, that you cannot read them anymore. So in Anira, just try to make them legible. If it becomes smaller and smaller, you may add like an arrow version. You might find that in like science figures, such as the percentage of other gases at the atmosphere at 1% and all else are bigger portions, and that small 1% they just add a small arrow and then a bigger description and so on. So we're done with presenting qualitative data. Next, quantitative data. Quantitative, or what's this? Numerical data. They can also be summarized into the first one. We have a frequency table, but looking at this one, this is how it would look like. So frequency table. So for example, a teacher records scores on a 20-point quiz for 30 students in his class. So these are the scores of the 30 students. We have the 0 score, it occurs 2 times. So there are 2 students who got 0, 5, the score of 5, only 1, score of 12, 1, 15, 2. So the scores are here at this part. And then to organize this data, it would look like this. So just counting, sorting them, grouping the values, grouping like values. It's easy as that. Okay, so using the table, it would be possible to create a standard bar chart also from the summary, like we did for the categorical or qualitative data. Look at this. Would you rather have this Is there any problem with this? Is this a good one? So notice that the intervals here are 1, plus 1, plus 1, plus 1, plus 1, plus 1, and so on. But notice here that the intervals 0 to 5, you have 0 to 5, and then 5 to 12, and that's 7 points apart, and then again 12 to 15, 3 points apart only. So the interval here, if you would make such a kind of table, the interval would be not uniform. So since the scores are numerical values, the chart doesn't really make sense too. So the first and second bars are 5 values apart, while the latter bars are only 1 value apart. It would be more correct to treat the horizontal axis as a number line. So when we start treating the horizontal axis as a number line, this could potentially make a histogram. Histogram is like this. It's a bar chart, it's a bar graph, but the horizontal axis is treated like a number line. The numbers here are continuous from 0 and so on. Okay, so for the example, number 7, so for the values given at the scores here, if we make a histogram out of this, it would better look like this. So you would see also how spread the values are. So from here and so on. So there are also times when, for a while, okay, so there are also times when we have varied amounts of data, and some of the frequencies are some of the values are wide from one another. This time we can group them in what we call intervals. So if we have a large number of widely varying data values, creating a frequency table that lists every possible value as a category would make you a very long frequency table. So you list each, and this would not help you in looking at the patterns. So for this reason, we have this what you call class intervals, so grouping the values. So class intervals are groupings of the data. So you're shortening it into groups and then you're counting the frequency. So in general, we define class intervals so that each interval is equal in size. For example, if a group or interval contains values from 120 to 129, the second class should include values from 130 to 139. So they are of the same size, but they don't overlap from one another. 129 belongs here and 130 belongs here. We have somewhere between 5 and 20 classes typically, so not so long, depending also upon the number of data that we're working with. So it's better to also have the classes in like multiples of 5. Okay, so class intervals are groupings of data. Yes, let's now have our example. Suppose that we have collected weights from 100 male subjects as part of a nutrition study. So you're getting the weights of mga male nga people. So for our weight data, we have values ranging from a low of 120 pounds to a high of 263 pounds, giving a total span of, what's this, 263 minus 121, 142. So if you would want to make a long number line for this one, taas jud kayong 142. So to shorten that, ato siyang break down into groups. So we would then create 7 intervals with a width of around 20. So there is a way also to summarize that or to make your intervals to determine how much and how wide. Just follow the link that I gave also in your SLHD. So oftentimes we have to experiment with a few possibilities to find something that represents the data well. So let us try using an interval width of 15. And we can start with the lowest one, 121, or maybe before that, 120 para multiple of 5. So since it is a nice round number or a multiple of 5, so if you make a frequency table, it would look like this. So 120 to 134, so 15 iyang width was it 120. So you start counting from 120 and so on. So 15 values ang naa sa usa ka group. And then you count dayon pila ka buok ang nasulod diha. So given natin 4 ba kaya or 14 and so on. So again, if to have a specific instruction on how to make the class interval, just follow the link. Okay, so it would be, if we make a frequency, if we make a histogram out of this, we can have this. So the histogram would look like this. So each range, okay, so each of the values, for example, at this group, 120 to 134. So 4 ang yung frequency diri tungoda. Okay, next na group, 135 to 149, 14 kabok ang na-occur. 14 kabok nga mga wala pa ta kay balo kay wala man tay data. Let us see. Okay, it's not given. Okay, so also if you have mga softwares like mga Excel, Microsoft Word, Google Docs, or OpenOffice, you can also make your own class, a graph and graph sa histogram, and you can have the labels put like this. Instead of inani, pwede sad maginani. So the class interval would be now the label. Okay, just follow the link again for more details. So after that, you now know how to make a frequency polygon. So a crude way of how to make a histogram. So next to that, something related to the frequency polygon is to a histogram is a frequency polygon. So sometimes also we can go to a deeper kind of representation of the histogram, and we are now making mga lines. So it's an alternative to the histogram. A frequency polygon starts out like a histogram, but instead of drawing a bar, where is my pen? Instead of drawing a bar, a point is placed in the midpoint of each interval at the height equal to the frequency. So typically, the points are connected with straight lines to emphasize the distribution of data. So for example, if you have this, I showed it already. If you have this, so the midpoint value be here, and then you try to connect those from your 0 value. So assuming that I am able to make straight lines. You can really do this in a computer software. Para easy. So look, it could look like this. For example, in a kind of graph that tells you mga reaction times. So inani ang frequency polygon. So it can show you also the spread of the data. Okay. Now let's go to the numerical summary. So we're done with that review and some inputs on graphical presentation of qualitative data and quantitative data. Then after we are presenting them in this graphical form, let's go more into using the numbers and being able to analyze our data. Okay, so before I start that, the first step in analyzing data is knowing how to describe them. and it usually starts, or it usually means getting ourselves with the world of statistics. So describing data usually means computing a set of descriptive statistics. So we say descriptive statistics ang term because they describe the general characteristics or a set of scores, of those values. So that is why when you give the descriptive statistics, you're trying to tell your audience on the general information about sa imong, or the general description of the values that you got. So it's like accurate first impression sa imong mga values. Okay, so let's now start. So it is often desirable to use a few numbers to summarize a distribution or a set of organized na mga data. So one important aspect of a distribution is where the center is located. So take note, first we're going to describe the center. So this is what you do in the measures of central tendency. Another aspect of describing your data is that how much is the data spread out or distributed. So the aspect of how it is spread out. So in other words, muna gitawag nga measures of variability. Let's go. The first one, measures of central tendency. So sa center. So in the center, you're trying to get the average impression of the whole data. So many people hear the word average, and even us would nakatry na tag-average, and when we hear the word average, ang atong mahuna-hunaan jud kay katong i-add tanan o i-divide kung pila sa nakabuk. But in statistics, average means many things also. So first, average could mean katong una nga itawag na to nga arithmetic mean. But in the measures of central tendency, we have, I think I've mentioned this already. So we have three types of averages, mga averages. Arithmetic mean is just one, but the other two, we have the median and the mode. Averages or measures of central tendency. Let's now start. This would be just a review for you if naka-remember pa mo ani from your first year. I think I have noticed the first years who have studied this one, or the grade 7 students, so more nag-review sa inyo. And hopefully, being able to know the math, main taog, you also know how to interpret or give the meaning out of this one. So the mean is the mean of a set of data is the sum of the data values divided by the number of values. So i-divide nimo pila sila ka buok. So it's easy as this. For example, the exam scores of Marcy from her last math class were 79, 86, 82, 94. And the mean value, or the arithmetic mean, you add and divide 79 plus 86 plus 82 plus 94 divided by how many? 1, 2, 3, and 4. So it would look like this, and the answer is 85.25. We usually have at least 2 decimal places. So typically, we round means to more than, or to one more decimal place than the original data had. So in this case, we would round 8.25 to 85.3. So there's an additional rule, so I have mistaken. So Anisya, when we divide 8.25, but our given values have no decimal place, so just one more decimal place than the given value. So punan mo siya gusa. So just round it to 85.3. If the values are, for example, 12.5, 12.6, so if you average them, the value would also, you add one more. So dapat duha ang decimal places. Okay. Another example. 100 families in a particular neighborhood are asked of their annual household income to a nearest $1,000 or $5,000. And siya, so USA ang example. The results are summarized in the frequency table below. So, na ay unom ka households ng ang ilang income kay $15,000. And so on. Okay, so bawat isa 15 kaunom ni occur. Ang 20 ka 8 ni occur. Ang 25. So if you list that one, 15, 15, 15, 15, 15, 15, 15, 15, 15, 15, 15, 6 niya, 20, 20, daga na po kayo, taas kayo na siya. So, it would get tricky. So, it's like 15 unom ka buok times 6 niya, 20 times 8, 25 ka 11, and so on. So, if you add all of them, we could calculate this more easily by noticing that adding 15 to itself 6 times is the same as 15 times 6, so 90. So using this simplification, we get this one. So how did that happen? Let me just write it and solve it for you. So this is what you call a weighted mean. Weighted mean. Each occurrence or each value 15, i-multiply nimo siya sa yung weight or yung frequency. So, inani 6 multiplied by 6. As this dot is a symbol for multiplication also. Then i-add na pud nimo sa sunod na pud 20 nga value kapila ni occur ka 8. So, plus na pud 25 11 times plus 30 17 times ni occur. Multiply na siya. Let me just have it. So I forgotten that wala pa siguro mo nakagi sa dot. Bas ang dot, ang meaning sa dot kay multiply. Let me use another one. So 15 times 6 plus 20 times 8 plus 25 times 11 plus, this would go an exhaustive list and so on. So what you do is x multiplied by its weight, yeah, plus and so on. And nya i-divide kung pila sila tanan. So pila man kabuk ang occurrence, kani imong i-count kay kung pila man ikabok na occur ang value. So 6 plus 8 plus 11 plus 17 plus 19 plus 20 and so on. So that is 100. So i-add nimo tanan ang frequency or yang total frequency. As much as possible, dili sa ako mag-introduce og mga symbols sa math para easy sa siya tan-awon. Okay? Inani ang weighted mean kung daghan. When you get to some schools or you get to college, inani sad pag-calculate ang mga grades. Or even karon ang inyong score sa science o sa research, ang inyong written work kay 50% of your grade. Ang inyong performance task kay 50%. Sa science lang yung sa research o sa ubang elective. Okay, so muna dayon na inyong grade. So kani inyong written work, so tanan ninyong score, i-count to siya tanan, yun na i-divide kung pila ka buok. Example, Pila to kabuk ang entries and teacher, 5 kabuk ang module. Unya kani kay performance task, mga 5 times sub mo nagbuhat og performance task. I-add to tanan niya, divide ako ag average niya. I-times na siya 50% times 50 niya. Muna din na imong total grade. Related din siya sa mga weighted mean. Next, median. So the median of a set of data is the value in the middle when the data is in order. Sometimes the mean is not a good measure. When does that happen? For example, your median is like ang inyong mean, because you have a seesaw, your mean is like the kind of masyag weight nga nasa center, this one. But sometimes the values that you get iwi jud akong kuan seesaw. Sometimes most of the values that you found are here. Yan ay masimang isa kabuok nga bugat daw siya na. So sometimes layo ra kayo siya, sira jud isa, sila tanan na adiri nga values, so masimang. So that is when you use, or kaning masimang muna gitawag nga si outlier. So that is when you use a median. Okay, so find the median, begin by listing the data in the order of the smallest to largest or largest to smallest. So before mo mangita sa median or the center middle point nga data, do not forget to arrange the values first. Okay, so if it is odd, it is katong nasa center. If it is even, you get the values at the middle and divide it by 2. Okay, so example, para easy. So returning to the football touchdown data, we would start listing the data. For example, we have these examples here sa katong frequency. So the context is in your SLHT. So we have these values sa mga touchdown. And then, i-reorder ninyo muna din yung arrange nga order. Right. Okay, so this one. Okay, so if you do that, i-count ninyo asa ang median. If you just count how many, so that would signal you to look at the location. Unsa may location sa akong median number? So pila man kabuk na adiri? How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. So 31 data values. So in 31, i-divide mo 2, that's 15.5. So just round it to 1 or to 1 decimal place or something, a number next. So mahimo siyang 16. So ang imo di ay nga value kay ang ika-16th. So ika-15 man diri, so mao ni siya. See number 20. Muna ang median. So odd numbers ni sila. If you have the mean sa even, divide mo 2. For example, 1, 2, 4, 6, 8, 9, 1, 2, 3, 4, 5, 6. 6 ka data values. Unya, imong kuhaon ang center. Ang nasa center is 4 and 6. So you just add 4 plus 6. That is 10 divided by 2. You get the average ba? So it's 5. Anara. So next, ari na ta sa mode. So another average is the mode. The mode is the element of data set that occurs most frequently. Kinsa nga data ang kinadaghanan siya ni occur. So the mode is fairly useless data for measurements like weight and heights because it doesn't make sense to count ano man nga frequent a number. So it is or large nga mga numbers or interval type of data. It is commonly used for mga qualitative or categorical data, for which median and mean also is not appropriate to be used with. So, aritag example. So, katong example na to sa kinaunahan, simple ra jud. Kinsa na data ang kinadaghanag frequency? The element that occurs most frequently. Kinsa man? Si blue, green. Gusto niya yung example. So, arita ni green kay 5. Okay. So, it is also possible for a set of data nga daghan po siya mode. So, daghan siya mode unimodal, bimodal, trimodal, daghan. Sometimes pod walay mode or when that happens kay each of the values kay parehas. So, every value occurs only once or lahi dili parehas. So, occurs only once. So, 1, 2, 3, 4, 5, 6, and so on. So, wala siya nagbalik. So, wala po kay mo. Okay. So, knowing the type of, knowing when to use it accordingly, given a type of data, diha na mahimong useful ang imong paggamit sa measure of central tendency. We can easily solve these, but being able to use them properly or interpret a set o type of data properly, dira na ka makakuha sa advantage ani nila. So you must be able to know when. So for the mode, it is usually used with nominal types of data. Such nominal data, mga categories, we have eye color, party affiliation, mga race, ana. Median, aside from mag-use ka ani kung naay outliers, it's also used with ordinal numbers because i-order man nimo, ranking numbers, rank in class, birth order, and so on, rank in a line, ana. Next, kaning mean, muna ni siya ang mag-use ka og higher types of data such as interval data and ratio, which have mga decimal ba karon, ana, continuous types of data na. So, we have example, speed of response, age in years, mga height, weight, mass, and so on. So, dira na mag-meaningful ang pag-use nimo sa mean. Okay. So, careful jud mo kung depende jud sa type of data mo gamit ani nila. Okay, next. So we're done with the measures of centrality or measures of central tendency or the averages. Now let's go to another aspect of the summary of your data, which is describing how varied, unsa po ka wide, ka spread out imong data. So consider these 3 sets of quiz scores. Let's try to solve the mean. Okay, and also the median. Okay, for section A, the mean is, diba, average, simple arithmetic average. So 5 plus 5 plus 5 to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 kabuk 5, that's 50. 50 divided by kapila kabuk na 5. 10. So 50 divided by 5, the mean is 5. How about the median? So center ani na dapat diri. So 5 plus 5 divided by 2. 5 plus 5, 10 divided by 2, it's also 5. So set B. So 0, 0, 5 ka 0, og 10 and 10, another 10, and so on. So, 5 ka 10 na po. So, imong i-add tanan, 0 plus 10. Ang answer kay 50 divided by kapulo ni balik. So, 50 divided by 10 is also 5. The median here at the middle again is 0 plus 10 kay even number man, i-divide by 2, same, 5. So, C na po na set of data. 4, 4, 4, 5, 5, 5, 5, 6, and 6, and 6. So, ang imong mean na i-add ni mo tanan, 12 plus 20 plus 36, that is 50. Yeah. Is it? 6 plus 18 plus 18 plus 12 plus 20, it's 50 divided by 10 kabuk. So, 5 gihapon. Unyang median niya, 1, 2, 3, 4, 5. Diri. So, 5 plus 5 divided by 2 is also 5. So, you can see that sometimes, at some values, pareha na silang mean of median. But, itanan mo diri sa data, here, lahi man jud, there is really a big difference. So, that is now the time to shine for describing how spread or how varied the values are. Okay, so we then use the measures of variation or dispersion. So we have range, we have standard deviation, and quartiles, and box plot. So kaning upat kabuok atong studyhan in the next slides. So let's go. Range. The range is the difference between the maximum value and the minimum value of the data set. Ana lang. So, unsa ka wide ang imong set of data. So, you get the smallest value, subtract it from the largest one. So, suppose we add another set with set D, section D. Ang mga scores daw sa mga bata kay 0, 5, 8 kabuk 5, unya 10. Kani. So if you solve the range, let's try. Kani sa section A, range is maximum minus minimum. Maximum value here, it's just 5 minus 5, 0. Kani. Maximum is 10 minus 0, 10. Maximum value. What I mean is, consider lang na to ang D. So, ang D lang day atong tanawon. So, the maximum value is 10 and the smallest value is 0. So, it's 10. So, looking at that section D, the range is 10. Yet, if we compare it also with other sections, like yun siya, napod siya, dapat more to this. So, after knowing the range, so, mas spread man siya kaysa uban, after na to gisolve, sayop di akong gi-erase. So, the section A, it's 0 ang yang range. Section B, it's 10 minus 0, it's 10. Nya, sa C, yung range kay 6 minus the smallest 4, 2. So, parehas ang section D. Ug ang kaning section B. So, even if they have the same range, lahi po ba nilang values? So, pwede pa mo gamit sa next na description. Standard deviation. So, the standard deviation is the measure of variation based on how far each data value deviates or is different from the mean. So, kaunsa siya pagkalayo sa mean. So, gigamit diri ang mean. So, a few important characteristics. Before that, ang standard deviation is one of the most common description of the dispersion of the data. And when you use also mga softwares, ang standard deviation jud ni kasagaran nga ihatag one of the things nga standard basic na ihatag dyan nila ang standard deviation. So it's time to know about standard deviation. Number 1, it is always positive. You will know later. Yun sana. And then the standard deviation is 0 if all the values are equal. So pareha atong 5 kaniha. Parehas man sila tanan niya pag solve it as a range 0 pa dyan ang mean kay 5. So if all the values are equal, 0. And then if the data spreads out a lot more, ang imo pong standard deviation magkadako. Then it has the same units as the original data. So for example, the values that you're solving kay mga height. So imong bang height kay in meters. Sa panadiha. So mousad na ang unit sa imong standard deviation. Okay, like the mean, it is also highly influenced by the outliers or katong mga data nga layo ra, far off ra siya or nasimang. So ma-influence din ang standard deviation. You will see why as we try to solve in this example. So nag-focus ta sa section D. Look at these are the scores from the students of section D. Okay. So first, what we're going to do to solve for the standard deviation is that you get the basic lang nga siya nga deviation. Unsa siya kalayo sa mean. Before that, unsay mean? So isolve sa nimo ang mean. I think we have solved this one already. So to get the mean is that you add all these numbers and divide it by 10. So 5 times 0 plus 1, 2, 5, 1, 2, 3, 4, 5, 6, 7, 8. 8 times 5, 40 plus 5 plus 10, 50. 50 divided by 10 kabok is 5. So ang mean na to is 5. So yung data value minus mean. So x minus the mean. Mean is symbolized as this. So atong buhaton is like this. 0 minus 5 is negative 5. Take note, negative siya. And then 0, save. Okay. So 5 minus 5, 0. 5 minus 5, 0. Okay, so 5 minus 5, 0 na po. 5 minus 5, 0. 5 So, save. And then 10 minus 5, it is positive 5. So that is your deviation. After that, if we try to add all these values here, the answers, okay, so if we try to add all these values here, the values would be adding up to negative 5 plus 0 plus 0 plus positive 5. Mo cancel siya, and the answer would be 0. So di siya pwede. It would always be 0 man if you do this. So mo na nga na sila gibuhat ilang gi-square ang mga deviation. So the deviation would be negative 5. Imong square. Ang 0, imong square. 0 square. I have really a bad handwriting because the tab is so slidey. So, square na nimo sila tanan. So, negative 5 niya square nimo, that now becomes 25. 0 squared, it's just 0. So, so this one. Okay, so if 5 squared, that is 25. So if i-add nimo silang tanan, 25 plus 0 plus 0 and so on, it's a total of 50. So what you're going to do next is that the total of 50, pwede na nato magamit diri when we solve the variance, sample variance. The sample variance is just the average nga distance. So 50 divided by ang total nimo nga mga distance, muna rin ang distance from the mean. So 2500. So imo ikuha ang mean. So 50 divided by 10, that's 5. So your population variance is solved with the total, kani nga total nimo x minus x bar niya square, your deviation squared, let's just write the wordings, divided by how many they are. So your n. Population nimo kay gamit ka og n. Capital N. But in sample variance, pa sa sample, nani siya statistics nga ang rules nila kay mag deviation squared, but they use n minus 1. So, assuming that it's if ang data nga imong gi-use kay population, you use all of these. You count pila ka book. So, for example, 10 ka book divided by 10. Pero if magamit tag sample from a sample nitong gikuha, which is most likely nga sample na jud ta, so we have to use katong formula nga naay n minus 1. So, your variance would be for example, deviation squared is 50. Kani sila tanan if total summation of deviation squared. Ang kani siya nga symbol kay summation total k. So your summation or gi-add nimo tanan na deviation squared, divide nimo og pila ka buok. Pila sila tanan ka buok? 10 ka values. 50 divided by 10, that's 5. Okay, mo yung sample variance. Next, ang imong deviation squared kay n minus 1. So 50 divided by 9. So what is that? Let's try to solve it. So 50 divided by 9, it's 5.5. 5.5. Daghana 5. Okay, next, we do the standard deviation now. In standard deviation, it is just not the same with the variance. So, ang variance, kay ato rang gikuha ang mean deviation. Mean deviation. It's like ang average nila sa tanang mga deviation. Ang usa kay population variance, kaning yun tanan, over 10. Kaning sample variance, n minus 1. There's like a statistical consideration nga no ga n minus 1 sila. Next, standard deviation. So, what we do in variance is useful, but the units in the variance kay ato naman siyang gi-squared, it was mura siya wala siya meaning. So ato siyang ibalik kay gi-square naman ato siya ganahan tang ato siyang ibalik sa iyang yung deviation kay kani man ta atong gusto nga part unsa gid sila kalay-a sa each other. Pero ma-zero man kung i-add na to ang average atong i-square. So karon kay nakuha naman ta sa average atong square root para mabalik diri. So population standard deviation formula is the square root of your deviation squared, your sum of your deviation squared over n, and your sample standard deviation would be sum nimo sa deviation squared gihapon divided by n minus 1. Ana. So you're trying to bring it back. Kay kaning variance na to, gikan man ni siya sa mga squared. So you try to bring it back from this. So nag-use ka og square root. Ana. So this is now your sample standard deviation. So if you solve 50 divided by 10, yeah, square root ana, square root of 5, kung na siya sa calcu, that's 2.2. Next. 50 divided by n minus 1. Pila ka buok minus 1. 10 minus 1, 9 ra. Square root is approximately 2.4. So, mo ni ang standard deviation. Naitay mga values sa population. Kani, sample lang. So, depende. So, you have to know kung ang imong data nga gamit kay about ba siya sa population or gikan siya sa mga sample. Sample is a subset from the population. So, if we are unsure of whether the data is, let me zoom it in at this part. If we are unsure of whether the data is a sample or a population, we will usually assume it is a sample. So we will just round the answers to one more decimal place than the original data also. So if ang data nimo kay walay decimal place, pula nimo gusa. If na duha ka decimal place, pula nimo gusa. And then sample man atong gi-assume, so magamit ka ning mga n-1 sa denominator. So if we summarize it all, kung unsa una siyang standard deviation, these are the steps. So to compute, you first find the deviation of each data from the mean. So ang kuha ni mong mean niya, gito sila kalay sa mean, i-minus na to. Subtract the mean from the data value. Next, atong gi-square ang mga deviation. Sunod, gi-add na to tanan, gi-divide by n, the number of data values, if the data represents the whole population. Pero kung sample, mag n-1. Ana. And then, compute dayon ang square root sa result. Ato siya gibalik kay gato man siya gi-squared. So, para mabalik siya, square root ang katapat. So, compute the square root. And that is now your standard deviation. Further on, you have examples found in your SLHT and you just read them para sa inyong time. You also discover on how to solve it. Try to solve it on your own para makibalo jud mo na mo'y mahinumduman. Now, let's go dayon sa quartiles. So, we can also have to describe the position of those values. So, quartiles are dividing the data in quarters. Gi-divide to siya kaupat quarters. So, the first quartile is go next. So, ang first quartile is the value so that ang 25% of the data are below it. So, example, you have a set of data points nimo na. And then, i-divide na to siya nga around quartile 1 is the value, so that 25% of the data are below it. So, siya daw ang upper 25%. 1, 2, 3, 4, 5, 6. Ganahan ko atong ipa multiple of 8. Okay, so the first 25% of the data values are below it. So, if divided in 4, kani nga value diri daw, siya mo'y quartile 1. Kay ang mga values na 25% kay nasa ubos niya. Next, the third quartile is the value so that 75% of the data values are below it. So, diri dapita. So, Q3. Para igtanaw nimo ang nasa ubos niya kay 75%. So, quartile 3, third quartile. And then, how about kung 50% of the data are below it? So, malamang nata dito nga ang median. Median is the 50% nga value or 50% yung position. So, once we know our positions, the data is now divided into katulo siya nga positions and divided into 4. We also have to learn the maximum value and the minimum value. So, before mo mag-start ani, imo sa judi in order. Listing in order. Dapat jud siya kay masayop jud na matibulaag imong data. So, this now gives you the 5-number summary. While quartiles are not a 1-number summary of variation, mura na siya measures of position ba kung asa dapit ang mga value. So, makaibalo na din siya sa 5-number summary nga gitawag. So, 5-number summary includes ang minimum, ang quartile 1 position, ang median, ang quartile 3, ug ang maximum. So, remember this. So, para makasabot tanong, maghatag tag example. So, the instructions first on how to find the quartile 1, imong pangitaon ang location. So, location sa gita, location. Do not look at the numbers first. Muna parehas pagpangita sa median. So, location 25% or 0.25 times the n, kung pila ka buok, nga mo din ng quartile 1. And then, if decimal, round up to L plus the next value, the next location. If whole number, ano na siya? Find the mean. So, third quartile, 75%. 0.75 times n. Same gyapon, locator lang siya niya. Locator sa jud. Dili nimo ang value jud na imong ma-solve. Example. Right. So, we're almost done. So, suppose we have 9 females and their heights are in inches. So, sorted from the smallest to largest. So, ato na siyang gi-solve. Ato na siyang gi-list. So, smallest 59 ato 72. Ito siyang buhatan og position as ang quartile 1, as ang minimum ag maximum. So, first minimum, muna si minimum. Kani maximum. So, 5-number summary, 5 man ka buok na natay duha. Next, para easy, kuha sa itong median. How to get the location of the median? Location of the median is equal to pila ka buok? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 divided mo 2. 9 divided by 2 is kuan kanang 4.5. Yeah, ang next whole number is 5. So, ang location niya is fifth value, 1, 2, 3, 4, 5. Muni ang median. Okay, next. Are we right? So the median is 66. Yes, we are right. Now let's go to quartile 1. Quartile 1 is ang 25. Si quartile 1 ang 25% below. Let me just erase that. To have that, let's have the location is equal to 0.25 of how many? We have 9. Muna yung n. So, times 9. So, what you do is 0.25 times 9, that's 2.25. So, 2.25, you get, oh, sayop na ta. Locator, 8 females? 8? Ang example, sayop na ko. So, referring to example number 17. So, 9 kabuok. So, 2.25, unya, it is a whole number. We round up to the next whole number. The next whole number is 3. So, location niya kay third. So, 1, 2, 3. So, mauna ni si quartile 1. Dayon, quartile 3. My handwriting is really bad. I'm so sorry. So, quartile 3 kay 70. Location niya kay 0.75 times n na to nga 9. So, what you do, type sa calcu is 0.75 times 9. 6.75. Next whole number is 7. So, at the position of the 7th number, 1, 2, 3, 4, 5, 6, 7. So, mauni si quartile 3. Ano na siya? Again, location ni siya. So, your 5 number summary now, minimum, comma, unsa gito next sa 5 number summary, quartile 1, comma, median, comma, Q3, dayon maximum. Minimum is 59, comma, quartile 1 is 62, median is 66, comma, 69, comma, 72. So those are the 5 number summary of your data. This works well if your data is kanang daghan jud siya. Kani medyo gamay ra man atong value niya. Dugol na pud ang mga numbers. So murag wala na siya use kay makita ra man nato tanan. Pero kung you have a set of data nga daghan kaayo, it's better to give your audience a summary. So imo gi-divide og kalima. Mo ni siya ang lima ka numbers nga maka-describe sa imong values kung mo siya mo-represent. So, 5 number summary. So, more examples are found in your SLHD. Just have the patience to read, and it's very easy to understand lang. And then, representing your quartiles is used with a box plot. We are now at the last part of this measures of spread or measures of variability. Learning from the last lesson, a box plot is a graphical representation of the 5 number summary. Maoday ni siya gikan. Kita mo atong box plot na nay mga line. So, to create a box plot, the number line is first drawn. Mag-drawing kag number line. And then, the box is drawn from the first quartile to the third quartile. Okay ha, mag-drawing kag box kuno nga gikan. So, naa daw kay line. You have to draw a number line. And then the box is drawn from the first quartile to the third quartile, and a line is drawn through the box at the median. So example, imong first quartile is here and here. Unya na ay median, for example, dada. Ay mana. Unya imong minimum ug maximum dayon sa to. Nawala. Imong minimum ug maximum kay diya dayon. So whiskers ni silang tawag nga gi-extend sa minimum to the maximum. So we'll try to draw our values from kaniha. Ay, sorry. Atong answer kay unsa ganito. Let me just check. So nakainumdum. 59, 62, 66, 62. 59, 62, 66, 69, 72. Am I right? 59, 62, 66, 69, 72. So, okay pa data. Okay. So, mo na siya 5 number summary. And what you do is mag-drawing kag number line. And then yung values, for example, mag-start ka diri o 55, 56, 57, 58, 59, so on. That's 60, 61, 2, 63, 64, 65, 66, 67, 68, 69, and so on. Maabot kag 72. Kay mo daw na imong largest value. Yeah, pwede po hantod pa ni mo 75. And yeah, what you do is you write a line sa imong smallest value, minimum, niya sa maximum, niya sunod another line sa quartile 1, niya sunod sa imong median pa jud. Later na si median sa imo sa quartile 3, asan si 69 here. And then from quartile 1, quartile 3, imo na drawan og box. Unya imo dayong median 66 sa man dapat si median dira tungod ana. So just draw kontiwason nimo nana ang pag-draw sa box plot. So having a more sophisticated drawing, it would look like this. Ana. So you can have it by hand or you can use the Excel to do this. Naa-adjust siya sa Excel nga muhimo ra siya inani input nimo ang data. Okay, another example, napatay daghang example sa SLHT, and this is one of them. And that is how easy it is. You can also compare two sets of data. Useful dyan box plot para makita. For example, unsa ka wide ang duha ka types of data. So kani siya, and then kani kay wide siya, medyo spread. Ana siya. So, for example, a box plot of service times for 2 fast food restaurants is shown below. Ang store 1, na sila'y mean sa usa store 2 kay 2.1, ang usa kay 2.3. But, ang 2.3 ilang service time, pero consistent sila, dugul-dugul na sila ang mga values. Dire kay 2.1 daw ilang mean, pero daghan na times nga madugay. So, not so consistent ang ilang service time. So, better di ay ang store 1. Ana lang. So, it is we're done with the different measures, and thank God nabutan sa diri na part. So, appropriateness of the measures that you are going to use is really very important. And the measures of central tendency and dispersion must be used properly, depending again on the type of data. So, natay summary ani nga table. So, muna siya. You can use the mode sa tulo. Median, not all. Nominal, dili pwede because they are not numbers and numerical ang value. Categories rin siyang nominal like name, age, name, colors, and mean you can use, but not all the time kay it would not give a good meaning man, not interpretable for nominal and ordinal. But kung interval data, continuous or discrete, pwede dere. variance and standard deviation because ang nominal ug ordinal dili man makuhaan og mean, so dili po jud mabuhatan og variance and SD. So only this one ang interval type of data kay pwede. So it really takes a good skill to know what type of measures are you going to use to describe your data. So our measurement decisions made while specifying this unsa nga mga operations atong gamiton, mo na siya consequence sa imong pag-interpret. And labi na ang mean, it is very sensitive siya sa mga mga outliers pod. So tan-aw pod nimo kano sa ka mag-mean, kano sa ka mag-median. So more on the meaning behind these numbers, more the interpretation pod in the next meeting, and I will try to elaborate it more. So for now, it's now your time to answer the exercises in your SLHD. I will post it in a sa katong mag-online class students. It is in a separate file. You can edit it and answer. So for the students from modular who are watching this, thank you so much for watching also. And then I will try to post another follow-up session for this. For now, thank you so much for watching and answer the exercises. So goodbye everyone.